All right, everyone. Welcome to the first idea in Math A. We're going to go ahead and start solving some equations. So first, we're going to go ahead and talk about one step. One step means that we're going to need to only do one simple operation in order to get to my answer. So we'll either undo subtraction, addition, multiplication, or division. So first, we're going to go ahead and look about getting our x value by itself on one side. If you notice, my x plus and my 9 are on the left side of my equation, or my equal sign, and the 3 is on the right all by himself. The idea is to get the variable, or in this case my x, on one side, either the left or the right, and all of my other numbers on the opposite. So again, if my number is on the left, if my variable's on the left, I want my numbers on the right. If my variable's on the right, I want my numbers on the left. And we're going to do what's called inverse operations. An inverse operation undoes something. So for example, you write on a piece of paper, your eraser undoes your pencil mark. If you have those fancy pens that erase themselves, then that eraser undoes your pen mark. So today's idea is to undo what's going on. So again, we said that we have addition going on. I see 9x plus 9 as I'm dropping all my things. So since I have x plus 9 here, I'm going to go ahead and subtract both 9 to both sides. By doing so, the 9 and the negative 9 cancel out. They're gone. And all I'm left with on the left side is x. The equal sign comes down. And then I'm going to go ahead and take 3 minus 9. So I had $3, I borrowed 9, how much do I owe? -6. In the second one, I see I have f minus 2 is equal to 11. In order to undo subtraction, I need to use addition. So what do I do to one side? I do to the other. The -2 and the 2 end up canceling out, and I'm left with my f. And then 11 plus 2 is 13. Next idea, I have my z and my -4, they're stuck together. Now when they're stuck together with multiplication, even though it's invisible. So to undo invisible multiplication, I'm going to divide. And since my 4 is negative, I need to bring that negative sign with it. So z is equal to -12. And why do I know it's negative? Well, originally my 48 is positive. Positive divided by negative should give me negative, so my answer should be negative. My next example, I say I have a division sign or a fraction. Fractions are undone, or division's undone with multiplication. I'm going to multiply both sides, whatever is on the bottom, in this case a -3. So those will cancel out, and I'm left with m equals -27. Now we're going to go ahead and try some two steps. All right, so I have this division first that I want to undo, and to undo division, I multiply. So I'm going to multiply on both sides by whatever's on the denominator. So in this case, the 6. It's going to cause that 6 to cancel out, and that 5 is on top, so he's a multiplier, so he stays as big as the m, and then I get 60. And I divide both sides by 5, and m is equal to 12. So 2 steps. Last time we only had to do one thing. This time we have to do 2 things. Again, I'm going to start by going and multiplying by whatever's on the denominator. Now before the negative sign here in front, let me highlight that for you. That negative sign that's right there. He can be done in either multiplication with the 4 or when I do the division of the 3. Either one will work. Now, if I use it with the 4, I need to remember that he's no longer there. I'm going to leave it with the 3. I always leave my signs with whatever number is on top. So I get 36 is equal to negative 3 times y. Again, notice how I brought the negative with. Now I'm going to divide both sides by negative 3. Again, we have negative not 4. I have a positive divided by negative. Positive divided by negative. So my sign should be a negative to end with. Now we're moving on to our 2 steps that cause a little bit more. It's still only 2 steps, but I have more than just one thing going on. Last time I had multiplication and division at the same time. Easy peasy lemon squeezy. Now I have multiplication and subtraction. So typically, I'm going to scoot this down a little bit. Typically, we go based on our order of operations, our parentheses, our exponents, multiplication or division from left to right, addition or subtraction. I see it, didn't move it down far enough. Left to right as well. However, when I do this guy, we're going to go backwards. We're going to flip him upside down. We're actually going to undo, we're actually going to undo our addition and subtraction first. So I know it's kind of upside down. It's like, oh, I can't really see that, but I think you know what I'm saying. So we work backwards. Right now I have subtraction. I have that negative 4 here. I have minus 4. In order to undo that, I'm going to add 4. So the 4 and the negative 4 cancel out. So I'm left with 4y is equal to 20. My next step is multiplication or division from left to right. In this case, I have multiplication, so therefore I'm going to divide. Oh, that's a funny y. And 20 divided by 4 is 5. Actually, I'm going to steal that. I'm going to, there it is. Keep losing my mouse, I'm sorry. Put that guy right in the middle there. Because we're going to use him for this next one too. Woo! All right, we're going to go ahead and start with the one on the left because we like writing in order. So first I'm going to take a look. I'm going to undo my addition or my subtraction. I see z divided by 3 minus 7. So I have that subtraction right here. So in order to undo subtraction, we're going to add. So those guys are buddies. So we're going to add 7 to both sides. Negative 1 plus 7 gives me 6. So I have 6 is equal to z divided by 3. So now I'm on to the next line, which is I have division. So I need to use my multiplication skills. So I'm going to multiply by 3. And I'm left with 18 is equal to z. Now remember, if I write 18 equals z, that's the same thing as z is equal to 18. It does not change. All I've done is just write it in a different order. You've got friends, you can talk about this friend first and this friend second, or you can talk about this friend first or this friend second. It's the same thing. All right, number 2. Now, typically we undo our division, our addition, and our subtraction if they are separated. But, as I highlight this guy, the division of 8 happens to the whole thing, doesn't he? It's going on to every single piece. So because everything has that division, I have to identify him and isolate him first. Whereas if I looked at the problem ahead, only this guy had the division. The 7 was off by himself. So when I have the addition, when I have the division going to everything, I have to undo him. So I'm going to start by multiplying both sides by 8. So I get y minus 13, because again, these 8s are gone, is equal to 112. Now, since I have the y by himself, I can go back to my original guy, my original thoughts, and undo my addition and subtraction. So we get 125. Okay, now we're going to take a look at combining like terms first. So if we notice on the one on the left, I have 8y and 3y, and they're on the same side of the equals. If I identify, if I highlight it for a moment, we're going to actually highlight it. I kind of like that a little bit better. Use the green. See how they're on the same side? Those guys are to the left, and the 44 is to the right. So when they're on opposite sides, and I have the same things together, I can go ahead and combine them. So I'm going to start by combining those guys. So 8 plus 3 gives me 11. And then I'm left with my 44 on the other. Okay, now we're at a one step. We can go ahead and divide both sides by 11 to get y by itself. So y should be equal to 4. Sometimes I have more than just 1 or just 2. I have 3. I have 3 guys. So we need to do everything I see. So I have a positive 12 plus 14 more plus 10. Which gives me 36x, which is equal to 80. When I divide both sides by 36, though, x is equal to 80 over 36, which is what I can divide both by 4, which would give me 20 over 9. And that's as far as those guys could reduce, or it's also equal to 2.22. I would prefer either this solution or this solution. Don't give me the unreduced form. All right, so if you notice, we have 6c, a little too long, 6c and negative 2c on the same side, even though the 8's in the middle. So we're still going to attack this guy the same way. So I have 6 minus 2, which gives me 4. And now I'm at a normal 2-step. So I'm going to go ahead and add 8 to both sides, because we have to undo our addition or subtraction first. Negative 6 plus 8 gives me a positive 2. And then I'm going to undo my multiplication with division. And c is equal to a half or 0.5. Again, reduced or the decimal, not the larger version of it. Always give me the reduced one. Okay, next we're going to talk about distribution. So distribution deals with multiplication, so we have to deal with that first. If, again, we recall our order of operations, it tells me simplify inside the parentheses. So if I look, well, m and 1, that's as much as I can put them together. They don't have anything else in common. Exponents don't have any exponents. Multiplication or division from left to right. I have some multiplication. Hey, I have some multiplication I haven't done yet. So I have to go ahead and distribute the 2 into both pieces. So I have 5m plus 2m plus 2 equals 23. Now I can go ahead and combine my like terms on the same side. So I have 7m plus 2 is 23. Next, I'm going to go ahead and subtract my 2 over because we're undoing that addition. So I have 7m equals 21. Divide both by 7. M is equal to 3. Okay, the next problem, there's a couple different ways to tackle it. They're all the same. It'll get you exactly the same answer. I'm actually going to put it on its own slide so I can show you all of the different ways that it is possible to be done. Because I really like this problem for this exact reason. I meant to separate it, and I don't know why I didn't. And I'm going to do this so that I can do the 3 different types. Oop, that's not a straight line now, is it? There we go. Okay, first ways first is we're going to do normal distribution. We're going to go ahead and multiply in the 3 halves to the x and the 3 halves to the -5. So there's an invisible 1 in front of the x. So when I multiply a fractional whole number, I take it's the first number on top times the top and bottom times bottom. So 3 times 1 is 3, 2 times 1 is 2, and the x comes along. Screen's not shaking a little bit. Okay, 5 is 5 over 1, so 3 times 5 is 15. 2 times 1 is 2, and that equals -6. Now, I don't really like to work with fractions if I don't have to. So I'm going to go ahead and I'm going to multiply everything by the denominator. And in this case, both denominators are 2. Oh, sorry. I hit the side of my screen and it zoomed everything out for a second. So I'm going to multiply by 2 to get rid of all the denominators. Now, when I do that, that 2 crosses out, that 2 crosses out. But there's nothing to cross out with the 6. So I have 3x minus 15 is equal to -12 now. So now I can go ahead and approach it like normal, add 15. You have 3x is equal to 3. Divide both by 3. I'm starting to write into my face again. And then x is equal to 1. So we see our answer should be x is 1. Let's keep that in mind to solve the same problem, again, in a different variation. Okay, there's nothing added or subtracted to the number on the right side of the equals. So I can start by just getting rid of the fraction, like I eventually did in step 2. So to get rid of the fraction, I multiply every single thing by 2. Well, that causes that first 2 to go out. The parentheses are left alone, and I'm left with 3x minus 5 is equal to -12. So instead of multiplying by 2 later, like I did here, I multiplied by 2 first. So then I'm left with 3x minus 15, because I'm distributing, is equal to -12, which is exactly what I have right here in purple. Notice how those two match? Hey, same steps will eventually get us to equal 1. Now let me show you my third way. Now you might have heard this term, you might not have heard this term. Try and get it engraved in your brain. It's called the reciprocal. A reciprocal is the flipped version of a fraction. So instead of 3 over 2, I'm going to multiply by 2 over 3. And again, what I do to one side, I have to do to the other. My 2 on top and my 2 on bottom will cause each other to cancel. My 3 on top, my 3 on bottom will cause each other to cancel. So the only thing I'm left with on that left side is x minus 5. However, I need to go ahead and multiply this guy through. So I'm going to take top times top, bottom times bottom. So 2 times -6 is -12. 1 times 3 is 3. Well, hey, we've been working with fractions a little bit. We know we can reduce him. -12 divided by 3, well, that's just 4. and it's going to be negative 4 because it was negative 12. So solve simply, add 5. X is still equal to 1. Same problem. 1, 2, 3 different ways to approach it, and we got the same answer every time. Okay, let's take a look at variables on both sides. There are 4 different ways to start this problem. One is not more right than the other. They're just all different. And I'm also going to do this too. I'm going to show you if I have enough room on this slide. I might have to, yep. We're going to have to halvesy it this way. We're going to go through all 4, and I'm going to show you how they're slightly different. They just start exactly the same way. Or I'm sorry, they'll get you exactly the same answer. So one way to start by doing it is to getting your variables on the left side. So remember left, right. So in order to get your variables on the left side, I have to undo my variable. So my 6 currently is positive. There's an invisible plus sign in front of him. There's no subtraction, so he has to be positive. We can assume that. If I don't see a minus, then it's assumed to be positive. So to go ahead and get rid of them, I'm going to subtract 6 to both sides. So 8m minus 6m is 2m. The 5 comes down. These guys are gone. And so we're equal to 1. Next, we're at a normal 2-step, so I need to get my numbers on one side, letters on the other. So minus 5. So I have 2m is equal to negative 4. Last step is to divide by 2. So m is equal to negative 2. Oh, first way is getting your variables, on the left side. Okay, now let's get them on the right side. So instead of subtracting the 6, first I'm going to subtract the 8. So I have 5 is equal to, because those guys are gone, 6 minus 8 is negative 2. Bring down the 1. Now I'm going to go ahead and subtract my 1 over, and I'm left with a 4. And my last and final step is to divide by negative 2. And 4 divided by negative 2 is negative 2. Hey, look, it's the same answer. Probably helps if I scroll down a little bit so you can see them. So first we've moved the variables. My next 2 are by moving my constants. Now remember, a constant is a number all by himself with no variable attached. So 5 is a constant and 1 is a constant. So let's get to the constants on the left side. So I'm going to start by subtracting 1. So I have 8m plus 4 equals 6m, and they're gone. Well, now I need to get the variables together, so minus 8m they're gone. So I have 4 is equal to negative 2m, and then divide both sides by negative 2. Hey, look, m is negative 2 again. What? Crazy. And my fourth way, getting my constants onto the right side. So I'm going to start by minusing my 5, or subtracting my 5. If 8m is equal to 6m minus 4. Next, I'm going to subtract my 6m. And I have 2m is equal to negative 4. Divide by 2. M equals negative 2. So again, when you approach I'm going to clean one of these up. When you approach a problem that has variables on both sides, constants on both sides, there are 4 different ways to approach that problem. One is not more right than the other. One is not more simpler. They took exactly the same amount of steps. I just didn't change my last color here. It really doesn't affect it. It's just different. All right, we learned all 4 ways. Pick one, come up with a solution. We'll see if we agree. Oof. Welcome back. We should see that we get b is equal to -7. Does it look like I skipped a couple steps? Yes, because I did. I can do most of these in my head, or at least 1 or 2 steps shown. So I didn't want to say, hey, this one's more right than the other. This one's better. This is just my process of how I do it. So hopefully you got to -7. All right, so we're almost through. Next, we have to talk about our special cases. This is something special that'll happen with the following things. Okay, so I have parentheses on both sides, and I have multipliers on both sides. So unfortunately, the only thing I can do is to multiply that in. Since there are numbers on both sides and there's a set of parentheses on both sides, I can't divide it over like I did with where'd he go? Whichever one I did 3 different times. There it is. Like this guy, where I went ahead and multiplied first. Because I don't have just a single number like I did here, I have to go ahead and distribute that through. So I get 12x plus 6 is equal to 12x plus 6. Well, then if I do this, they're gone and they're gone. Wait, what? And then I'm left with this, which that makes sense, right? 6 is 6. It's not saying 6 is like 12. That makes no sense. If I have $6, I want to have $6. So if you get what's called a true statement, like 6 is 6, 7 is 7, 100 is 100, then your final answer is infinite. I can spell real good today. Is infinitely many solutions. So because I got a true statement, 6 is equal to 6, my answer is infinitely many solutions. It means that anything I plug in will make this work. And this is true for every single number, no matter what I pick. So say I let x be 7, I will get the same number out. I will get another 7 at some point. So this is what's called a special case. Okay, let's take a look at another one. I have more than just a number on the left side, so unfortunately, again, I do have to start by multiplying him. So I have 2 minus 15n is equal to negative 15n plus 10. Again, one is not more right than the other, different ways to try it. Personal preference, like my variables on the left side as possible or positive. So if I know by moving my variables to the left side, it's going to make a negative, I'll move it to the right side. It doesn't matter. I like positive variables. Sometimes it's unavoidable. That's okay. So I'm going to go ahead and add my 15n to both sides. Well, this one canceled out like I wanted it to, but negative 15 plus 15 more cancels out again. So I'm left with 2 is equal to 10. Is that? I mean, that'd be cool if I had $2 and it was the same as $10, but that wouldn't be fair if I had $10 and it's telling me I only have $2. Like that's not cool. So we have what's called an untrue statement. When we get an untrue statement, something that does not make sense, this is not equal, 2 is not equal to 10, our answer is no solution. because there is no possible value for x that'll ever make this statement true. Whew, finally done. Hope you learned some stuff about variables.